Hello all. In the last video, we have studied about the crystallinity and polymorphism properties of the drug while developing a stable, safe and effective dosage form and how it will help to develop a stable, safe and effective dosage form. Now in this video, we will study about the next physical properties, that is the hygroscopicity. How it will affect during the formulation development. So we all know that water soluble salt forms are having tendency to absorb water, and generally it depends on the atmospheric humidity, temperature, surface area and exposure. And this moisture absorption will generally influence on a chemical stability, flowability and compactability. So we know that the determination of the moisture content, hygroscopicity and ability of that API to gain the moisture or the hygroscopic nature, we should know it priorly before the formulation development, because this information will help us to develop a stable dosage form. Then how we can measure the hygroscopicity? So there is one test, that is a test for moisture content. In this, samples are placed in open containers by making thin powder bed for the achieving more exposure to the atmospheric moisture. And then the samples are exposed to the range of relative humidities prepared with the saturated aqueous salt solutions. The salt solutions are made up of different humidities. Moisture uptake can be checked at the time points of 0 to 24 hours and storage of 0 to 12 weeks. We can measure the moisture content by different analytical methods such as thermal gravimetric analysis, gravimetry, Karl Fischer apparatus. So this is one of the important property we should consider during the pre-formulation to develop a stable dosage form. The next property we should study during the pre-formulation is a fine particle characterization. It should be tested during the pre-formulation because it is required to produce homogeneous dosage form. To make a uniform particle size, we should do the fine particle characterization and to maximize the surface area for the internal actions. So the study of particle size gives an information about solubility, dissolution rate and absorption. So particle size and surface area of the solid drug are inversely related to each other. The next important physical property is powder flow properties. The flow properties of a powder will determine the nature and quantity of the excipients needed to prepare a compressed or a powder dosage form. As we know that if we know about the flow properties of the API, then accordingly we can select the excipient at the time of granulation. If we are having if our API is having less flow, then we need to add some glidants like talc, magnesium stearate, into the starch into the formulation. Okay, so accordingly, powder flow properties should be considered properly, which will help to select an excipients. The next aspect of pre-formulation will start here, that is a solubility analysis. In this, aqueous solubility we should consider. So important objective of the pre-formulation study is that to set a method for making solutions of a drug. An orally administered drug must dissolve in the aqueous fluid of the GIT before its absorption. Solubility can be improved by addition of the co-solvents. The next parameter of the solubility analysis is drug pKa and ionization at physiological pH. That is, the pKa is the dissociation constant of the drug, and the non-ionized substances are lipid soluble. Thus, it should dissolve in a lipid material of the membrane and transported by the passive diffusion. Whereas the ionized substances is a lipid insoluble, therefore permeation is slow. So percent ionization can be calculated by using given formula for acidic compounds and for the basic compound. See, the degree of ionization depends upon the pH. For acidic drugs, pKa ranges from 3 to 7.5, and for the basic drugs, pKa ranges from 7 to 11. The next parameter of the solubility analysis is the partition coefficient, which is the measure of lipophilicity of the drug, which is an important parameter we need to consider during pre-formulation. Partition coefficient is a ratio of equilibrium concentration of a drug in an oil phase to equilibrium concentration of drug in an aqueous phase, as given in the formula. whereas CO is the organic phase concentration and CW is the aqueous phase concentration. Following the administration of the drug, it must go through a variety of membranes to gain the access to the particular target area. And drug with the extremely high partition coefficient, that is very oil soluble, readily penetrates the membrane. And while the drug with the excessive aqueous solubility, that is low oil water partition coefficient, cannot penetrate the membrane. So this is one of the important parameter we need to consider during pre-formulation. The next parameter is the dissolution. To know the gastrointestinal absorption and other physicochemical properties, the speed at which a drug substance dissolves in a medium is called its dissolution rate. For a chemical entity, its acid, base, or salt form, as well as its physical form, for example, the particle size, may result in a substantial variations in the dissolution. This is the dissolution apparatus. Okay. So here we stop for the today's video, that is for the solubility analysis. And in the next video, we will study about the stability analysis aspect of the pre-formulation.